Well, good afternoon, and thank you to the 10 of you who were able to come for this session and the 400 others who went for Mark's session. As I was remarking to a gentleman earlier, this is not a competition at all. Mark's session, I'm sure, will be wonderful. But thank you very much for coming. My name is Ravi Rao. I lead the cloud networking efforts on the Windows core networking team. And I'm accompanied by Dhananjay Mahajan, who leads the partner efforts in the SDN space itself. And in today's session, I'll be talking about software-defined networking, what it is, and it's a small audience, so if you want, we can make it very personal, and if you have questions, just feel free to ask at any time. So again, the agenda is pretty straightforward. I'm going to set the context on what the problem is, what SDN is, because it's a buzzword for the most part and is not really well defined. So we're going to try and define what SDN actually means to us. I'll then go and talk about some of the technologies that you would normally use to enable SDN and what we have available. And finally, Dhananjay will come up and talk about the ecosystem, how we have a rich ecosystem growing around the set of technologies and the overall SDN space. So with that, let's start with the context. So the big picture, as you may have heard in Brad's keynote, is transforming the data center. The idea being that you have that infrastructure basically appears to you as a pool of resources. They're not siloed. You have a pool of resources that are available that you can allocate flexibly on demand. So you can scale up the use of resources, scale down the use of resources, have resources allocated in a private cloud, in a public cloud, hybrid cloud. No matter how you want to go out and deploy, you have a pool of these resources available that you can decide how you want to use. You're not strangleholded by silos that exist within the data center. So that's kind of the vision around, transforming the data center, especially data center without boundaries. The second part is that given that we operate 200 plus very large services, we want to bring all the learnings that we have from what we have learned. How do you reduce CapEx when you're running a large service? How do you reduce operational expenses when you're running a large service? We want to bring all those innovations we have made in that space and bring them and make them available to everyone. And finally, once you have this model where you have a pooled set of resources available, then you have the ability to dynamically deliver applications on demand. So when the business comes and says to IT, hey, IT, I need you to go and host the SharePoint farm for me, it is a lot easier because you're not suddenly subject to a world where resources, even though available, if you just look at pure capacity available, it's available, but you still don't have the ability to allocate it. Okay, so that's kind of the big picture, that we want to transform the data center into this model where you have a pool of resources available that you can flexibly allocate from. So the problem in getting there in the networking space is that networking can get in the way. The physical network can get in the way. And so in this picture, what you'll see is that I assume folks are kind of familiar with VLANs? Yes? Okay. So think of VLAN as an isolation model, and so you have three tenants. You have a red tenant, a blue tenant, and a green tenant, and they're all isolated using VLANs. Okay. Now, a tenant, the red tenant comes and says, well, I need to go and get another VM. My tenant network needs to get expanded. I need to add a new VM into my tenant network. And so what happens is, the hoster says, okay, yeah, no problem. I have a machine available, and I can place the VM on that. The problem is you're not done when you do that. There's more to be done. You have to configure the VLAN tags in all the appropriate places. And so when you do that, you now have, in this case, 3 places where you now have to go additionally configure the physical network so that these VMs can actually communicate with each other. Okay, that doesn't sound very flexible. But let's say for a second that the hoster thought that the best place to actually host the VM is in a different rack. So on the other top of rack switch. So let's say the VM were to come there. Well, let's see how many changes have to get made for a scenario like this. That's 10 changes on a network for adding one VM into the network. That basically is the exact opposite of a pool of resources being available, because when you want to go now and say, I want to add a new VM into my network, what it's going to mean is that you're going to think, wait, maybe I should add it to this host because then I have to touch the network so much less. Right? That's not flexibility, that is inflexibility. And that's exactly the problem we want to get away from. We want to make it easy for people to be able to onboard tenants, onboard workloads, without having to go through the mess of having to constantly reconfigure the network anytime changes occur. So hopefully that explains what the problem is and how networking as it's designed today can get in the way. So some of the requirements that we look at are that in order to transform networking we need to deliver networking as a part of pooled infrastructure resources. You have resources that are available, you have bandwidth, you have host capacity. You should just be able to put a VM there if you want to. Okay? It should not be related to the need to reconfigure the actual network. The second is that networking needs to have the inbuilt mechanisms to allow IT to have a service provider mentality, which means that IT should be able to say, okay, I'm going to onboard 5 tenants. I'm going to ensure strict isolation amongst these tenants. I'm going to have SLAs. I'm going to have chargeback. I'll do metering if necessary. A service provider-like mentality within the IT organization itself. The third is to expand data center capacity seamlessly. And what that means is that, if you have a desire to expand capacity because you have, say, acquired a company, and now you have 2 companies, there is more capacity available, but how do you get these 2 things to talk to each other in the first place? Or if you want to scale up into Azure and you want to use the Windows Azure environment, it needs to be very, very easy to do these kinds of operations. And finally, you want to reduce operational expenses. And the mechanism to reduce operational expenses is to have as much automation as is possible. Okay, so those are kind of the requirements we see for transforming networking from where it is today to where we want to take it. So we started by saying that in the data center, we want to have this model where you have a pool of resources available. We found that networking, because of the way the physical network gets structured, gets in the way of being able to get there. And SDN is a mechanism to enable software to dynamically manage your network so that you are in command of the network and the network responds to what you want it to do, rather than you being held hostage to how it has been structured. So that's how we look at what the value proposition of software-defined networking is, that you're using software, because software fundamentally is a lot more, dynamic and flexible than hardware is. So you're using software to dynamically manage the network, and the network is flexible enough to respond to your business needs. And the way you do that typically is by having 3 steps, or not 3 steps, but 3 things. The first is you need to abstract the underlying physical network away with a virtual network on top. So that's in the same way as you abstracted physical servers and replaced them with virtual machines, which are so much more flexible. The underlying physical network now needs to get abstracted away as well. The second is you need to have policies now that span across virtual and physical boundaries, and I'll go into that. And the third is you need to have a model where you can enforce these policies on the network. Okay, so for instance, if you want to control how traffic is flowing on the network, you want to control how isolation is being enforced, there needs to be a place where you can do that. So that's the context I'm going to set, and now I'm going to go into the technologies that we think can help in achieving this vision. So the first question to ask yourself is, yes, the physical network is inflexible. Okay, if it is, how do you go and get control over a network that is not that flexible? I mean, you have your routers and switches are generally in a pretty static configuration. How can you get control over such a network in the first place? The way you do that is to move the policy edge of the network, okay, the edge where you go and apply policies from the physical switches that are in the network to the virtual switches on the host. So you have physical switches in the physical network. You move the policies from there to the virtual switches on the host. Because when you move the policies to the virtual switches on the host, you suddenly gain a lot more flexibility. Okay? Now, doing that requires a switch that is pretty rich. Because you're used to being able to do a certain set of things on physical switches, you now want to have the ability to do similar things on the virtual switches as well. And in Windows Server 2012 and Windows Server 2012 R2, we have a really rich Hyper-V switch, which provides a whole bunch of features. You know, it provides features around isolation, traditional VLANs, PVLANs, and the new isolation models that Hyper-V network virtualization brings. It has mechanisms for traffic shaping with QoS support for min and max. We have a whole bunch of security features in there with ACLs and extended ACLs and DHCP guards and router guards. There's a lot of diagnostics built into the switch. And probably amongst the most interesting things in the switch is that it is extensible. So the switch is extensible. It's not replaceable. It is extensible, which means that you can now have a rich ecosystem of partners building around it. So you can have, say, for instance, an S-Flow extension from one vendor, a firewall extension from another vendor, and a forwarding extension from another vendor. And all these will coexist on the same switch. Okay? So you have a rich switch that we provide that allows you to move the policy edge to the hosts, and it is extensible, which means that you have the ability to pick the partners you want to work with in order to get the choices you care about. Okay? So now that you have moved, the policy edge of the network to the actual hosts, you suddenly gain the benefit of automation. Because System Center VMM, for instance, and PowerShell are highly automatable. And so now you can create these logical switches with defined configurations associated with them and instantly deploy them to a large number of hosts at the same time. And anytime changes occur, all things on those hosts would automatically change at the same time. So you suddenly get a lot of control and flexibility in the network. So the next step, once you have that, the next step is to now start building customer overlays on top of it. So you have customers who come in and say, or your tenants come in and say that, well, I have a certain topology that I want to bring in, and I want you to host it. And a topology basically is a collection of IP addresses and subnets, just IP addresses and subnets. Servers and all the things that go with it. And so a customer says, well, I have, let's say a web server and a SQL server, and they talk to each other in a certain way. I don't want to host it. I want you to host it for me. Can you please take care of it? And don't change the IP addresses, please, because otherwise everything is going to break. So in order to do that, you have to build these overlays on top of these virtual switches that exist across all these hosts. Okay, so the next step basically is to build these overlays with arbitrary topologies that can span across hosts in any way you want. So once you're able to create these topologies, these arbitrary topologies in the network, then you get the benefit of VM mobility. Because now you have the ability basically to say that, sure, I don't care about what the underlying network is doing. I want to move my VM from one host to another host, and things will continue to automatically work. And on the next slide, I'll talk about how we go about doing that. So what's really happening is a customer, let's say Contoso, comes in and says that I have a SQL server and a web server. And these have two addresses. They use 10.1.1.2 and 10.1.1.3. They're basically using two different addresses. These are the customer addresses. So these are the CAs, as we like to call them. They're the CAs. These are the customer addresses associated with the VMs that they are bringing into the environment. At the same time, the hoster has their own provider address space, or the PA space. So the hoster has their own space that they are operating in. And in this environment, you have, for instance, each host has a certain address. In this case, one has a 192.168.110, and the other has a different address. So you have the PA space of the hoster, and you have the CA space that the customer is bringing in. And so what we do in Hyper-V network virtualization is to create a mapping between the two. So we create a mapping between the customer addresses that are being brought and the provider addresses where they are being hosted. Okay, so we'll say that the SQL Server VM is now mapped to the address of host 1 because that's where it's actually being hosted. And any time that changes, let's say you live migrate a VM, System Center VMM is going to know about it, and it'll automatically update all the hosts in the network with that information. Okay? So what happens now is that System Center VMM is going to take these mappings across all customers, different tenants, for instance, and plumb them down into the switches on the different hosts. Is this making sense? So you have System Center VMM. It has a mapping of the customer address space and the provider address space, and it takes those mappings and plumbs them into the into all the hosts that are on the network. Okay. So now once you have this model, you now have the ability to move VMs anywhere within a data center environment. VMs can now move automatically because as soon as a VM moves, System Center will update the mapping on the individual hosts on the network. Okay? So we had that foundation in Windows Server 2012. And in 2012 R2, what we're doing is we're allowing customers to bring more of their topology into the provider network. So while in the 2012 timeframe, we allowed customers to bring in their IP addresses, now we allow customers to bring in their DHCP servers. We allow customers to bring in their guest clusters, their host clusters. They can statically assign IP addresses to VMs, and all that just underneath the covers works. There's no manual reconfiguration needed for any of those scenarios to work. We also invested in a couple of performance improvements. So NIC teaming was a big investment area we made, where Hyper-V network virtualization now works with NIC teaming, so that you can both inbound and outbound, so that you can get optimal throughput possible on the hosts where it is being used. And secondly, we partnered with the hardware community around task offload. And the idea with task offload is that there are certain operations that hardware will always be able to perform faster than software will. So if you have, for instance, a simple example is large send offload, or LSO. In large send offload, what happens is you have an application that wants to send a big buffer. It wants to send a very big packet. But the network can't accept that. The network can only accept smaller chunks. And so what we do is with LSO, we directly pass that packet on to the NIC, the underlying network interface card, or the NIC, and the NIC then takes care of chunking, creating the necessary chunking, and it's wired up with all the circuitry necessary to do it as fast as possible instead of us doing it. Now, since NVGRE is a new protocol, it is a standards-based protocol, so it is a standard protocol, but it's a new protocol. We need these offloads to be updated. And so we've been working with our hardware community, and I'll show on the next slide what kind of benefits they're seeing. And the final thing we invested in are around enhanced diagnostics around Hyper-V network virtualization. And I highly recommend to learn about these capabilities, you listen to the video of Charlie Wen's Hyper-V network virtualization deep dive. It goes into really the details of how the technology works and how you use it, how you diagnose, so on and so forth. So the partners we worked with were Emulex. So Emulex basically found that without NVGRE offloads, they were seeing about 4, on a 10 gig NIC, they were seeing about 4 gig throughput. And when they enabled, with their NIC in place, they were able to hit close to line rate. Similarly, Mellanox found that fairly similar results on the throughput side, that you get a certain amount of throughput when you're doing everything in software, but when you have it accelerated through hardware, the throughput goes pretty close to line rate. And the CPU correspondingly drops as well. So because any operations that are done in software are going to have to involve the CPU utilization is going to be a little higher than what you'd normally expect. When you pass it down to the hardware, then things go a lot faster. Okay? So H&V, like I had said earlier, introduced the concept of a customer address space, which is the VM's address space, and the provider address space, or the PA space, which is the hoster's address space. And it creates a mapping between the two of them. Now, like I had said, with the Hyper-V switch, it is extensible. One of the benefits Hyper-V network virtualization brought into the picture is that in the R2 time frame, extensions now have visibility into both the customer address space and the provider address space. If you look at the software architecture in the 2012 time frame, we had H&V, if you see the box below, H&V, which is Hyper-V network virtualization, layered below the virtual switch. Okay, so when a VM was going to send traffic, it would flow through the switch. So all the extensions now can see the CA space, they can see the VM's address space, but they don't get to see the hoster's address space at all. Okay? And similarly, when a packet is coming in, H&V would decapsulate the packet, and only the customer addresses would make its way up into the switch. So the extensions in the 2012 time frame were not being able to see the provider address space, and they had a desire to be able to see it so that they can do interesting things on it. Maybe they want to apply ACLs on the provider address space as well, or do reporting, more interesting reporting with S-Flow, for instance. And so in the 2012 R2 time frame, we moved H&V into the switch. And by virtue of doing that, all extensions now get to see both the CA space and the PA space. They get to see the provider addresses, and they get to see the customer addresses so that they can act on them. And a nice side effect, a nice benefit of this is that in the 2012 time frame, forwarding extensions didn't necessarily coexist with Hyper-V network virtualization. So if you had the Cisco Nexus 1000V, for instance, the Cisco Nexus 1000V would not coexist with Hyper-V network virtualization. But we partnered closely with Cisco, and in the R2 time frame, we now have these two can coexist with each other. And the reason is we introduced a hybrid forwarding approach within the switch, where if you have a VM that's using H&V, then H&V would take care of doing the necessary forwarding. However, if it is not H&V traffic, then the extension would take care of forwarding that traffic, which meant that you now had the ability to support multiple network virtualization protocols if you wanted to. So as a customer, you're not necessarily locked in to using one virtualization protocol, like H&V, for instance. You have the ability, the platform is open and extensible to allow for multiple network virtualization protocols to plug in if that was the desire. So I was now going to demo this. This is a live demo. It's going to use the Cisco Nexus 1000V extension and show that it coexists with Hyper-V. So what you see here is System Center VMM, And in System Center VMM, I'm showing you the logical switches. And you can see that there is a Nexus 1000V switch. Okay? And that's just a name. And if you go in here, you can see that this logical switch has the Cisco Nexus 1000V forwarding extension installed. Okay? So now, once it's a logical switch, it automatically gets deployed to the set of hosts you want it deployed to. Okay? I have two logical networks. You can see that I have an HNV logical network, and I have a regular VLAN-based logical network. And you can see that the address space that these are using are 192.168. And similarly, this is using a different space. So I have two logical networks. One is for HNV, one is for regular VLANs. If I go into the VMs and servers and I look at the VM networks, and VM networks are the customer networks, the tenant networks that are being brought in, that are being overlaid on top of the underlying physical network, you can again see that I have two VM networks. One is an HNV network, one is a VLAN network. Okay? And if I go into each of these hosts now, I have some VMs running here. Okay? So now what I'm going to do is I'm going to start a file copy from both these VMs. So one is an HNV-based VM, one is a VLAN-based VM. So I'm going to start a file copy from the native VM, and ignore the red, and you'll see that traffic is beginning to flow. So you can see that, it is you can't read the counter probably, but it's native VLAN traffic that is being tracked here, both send and receive, and traffic is flowing. And here I have perfmon counters for network virtualization, Hyper-V network virtualization, and you can see that these are not really changing. But now if I were to start the HNV traffic, I'd start doing the same file download. Then you'll find that these counters are beginning to change, right? Because HNV traffic is beginning to flow, and you'll see that these two don't override each other, that both of them are now actually coexisting with each other. That fundamentally you have Hyper-V network virtualization, you have Cisco handling all the other traffic, and both these traffic types are coexisting properly with each other. Okay? Okay, so that was the first demo. Okay, so what we have seen thus far is to realize the SDN strategy, to realize an SDN within your environment, to get to a state where you have a pooled set of resources that can be allocated, we start with the virtual switch. You start with the virtual switch and say, I'm going to now apply policies within the context of this virtual switch. Okay, that's kind of where you start. And you saw that we have a rich, extensible switch that we have to offer. Once you have that, you now have a technology like Hyper-V network virtualization, which then overlays on top and has the ability to create these customer overlays, customer-defined overlays on top of it. And that this network virtualization protocol coexists with other mechanisms that are out there. So the third step from that point on is to say that if I have a topology that spans across virtualization boundaries. So let's say I have a VM in my data center that wants to talk to the internet. Well, there's no Hyper-V network virtualization on the internet. If you have a VM that needs to connect back to your corporate network, over a site-to-site connection, for instance, you may not have Hyper-V network virtualization in that environment. Or if you have a VM that just wants to talk to a physical resource, say storage or something, well, there is no Hyper-V network virtualization there either. And so what you need is some kind of a translator or a gateway that has the ability to translate from a Hyper-V network virtualization world to one where there isn't. And so for that purpose, in the 2012 R2 timeframe, we built in-box multi-tenant gateways. And the idea with multi-tenancy in the way we have done it is that instead of having, the way multi-tenancy is typically done, not always, but typically done, is that you spin up a separate tenant gateway VM per tenant network. So you have a tenant network, it needs to go and communicate, say, back to corporate. That tenant network is going to communicate with the VM, which is the gateway VM, and that gateway VM then goes and talks back to the corporate network. The problem is that's one tenant. If you have 10, you suddenly need 10 VMs. If you have 100, you need 100 VMs. And these things slowly start adding up, right? Because there is operational expense of running that many VMs, and in the end, this is just infrastructure overhead. So the design goal we set out with was to say that we want a single VM, gateway VM, to be able to host 100 different tenant gateway VMs. So a single VM has the ability in the 2012 R2 timeframe to be able to host 100, up to 100, sometimes more, sometimes less, different tenant gateway VMs, which then have the ability to go and connect back to whatever they're connecting to. The gateway that we built in the 2012 timeframe is highly available, and in many cases, connections that you have ongoing with the gateway will simply fail over to the new gateway anytime a failover happens, and the client won't even notice the difference. At the same time, we recognize that customers may want to use partner solutions. I mean, a customer, for instance, may say that, you know, this is all nice, but I have a big IP already in my deployment, and I want to be able to use my big IP and have it act as a gateway in addition to doing the load balancing that it does. Okay? So we partnered closely with the community, specifically with F5 as well, and F5 now has a software appliance, a virtual appliance that can be configured to act as a Hyper-V network virtualization gateway. Okay? And so I'm going to demo that to you next. So what you're going to see in this demo, I'll just tell you what you're going to see. What you're going to see in this demo is that there is a VM network, a tenant network, which identifies the gateway as the big IP appliance, and that this tenant is going to start up a browser, and he's going to try and connect to the internet, and that's actually going to work. Because traditionally that won't work, because it's NVGRE, or it's Hyper-V network virtualization traffic that is flowing through, but the big IP is going to ensure that the right things happen and the client actually is able to get to the internet. So what you see here now is you can see that there is a gateway plugin installed in SCVMM, System Center VMM. There is a gateway plugin installed, and this gateway plugin is basically what VMM talks to during configuration, and then the plugin goes and configures the gateway with the necessary policies. If I go into the fabric, you can see that there is a big IP gateway in the fabric. Okay? If I go into the VMs and services node and go into VM networks, you can see that there is a Contoso marketing network. And if I were to open it, you can see that this tenant network that the hoster is hosting uses the big IP gateway at the edge. Okay, so all traffic that is going to be going to the internet is going to be flowing through this gateway. H&V traffic is going to be flowing through it. So now I'm going to go to a VM, and I'm going to connect to one of these VMs. So I'm going to connect to this VM, and I'm going to attempt to open that page and hope that it works. These are all live demos. And before I do that, I'm going to get onto the actual big IP itself, and I'm going to reset all this data here so that you have the ability to collect statistics. I'm going to reset this data, and then we'll refresh it. So it's all zeros. So now I'm going to go in here and I'm going to try to open this page. So now I'm in the VM. The VM is going to the big IP, which connects to the internet. And it's able to open it, as you can see. And if I were to go back to the page and look at the stats and refresh, you can see that data actually went through it. Okay, so this is a third-party solution with F5 that we are providing that acts as a gateway in addition to being the load balancing solution that it already is. Okay, so that's... I keep putting the clicker somewhere. Okay, so what we've seen so far is we started with the switch. We said that we are making the switch virtual. We used Hyper-V network virtualization to create these tenant overlays in the network. And then to support scenarios where you have these overlays, needing to go and communicate with on-prem scenarios, like hybrid scenarios where you're talking back to corporate network, or you're going and connecting to the internet, or you're connecting to a physical resource. We have gateways, both inbox and vendor supported, that let you realize that scenario. Okay? So then, once you have these 3 steps, just these 3 steps, once you have them, you now have the ability to realize the benefits of SDN on the existing networks that you have today. There are no changes needed in your existing network. You can realize all those benefits in your existing physical network. No changes necessary. But we asked ourselves, can we do better if we actually had the ability to control the physical network? And so a scenario that came up is, well, if you configure VLANs on a virtual switch, you have to make sure that that actually is correctly configured on the physical switch as well. Because if the physical switch is not configured with the right VLAN tag, then traffic is not going to flow. So that to us said that, okay, in a data center network, there are a whole bunch of switches, and traditionally you have all these capabilities on that switch that are trapped on that switch. They are only programmable through proprietary means. And so we worked with the industry to create a DMTF standard schema to be able to control switches. So we used OMI and PowerShell, wherein the switch vendor basically went and implemented the OMI providers, and now we have the ability to use PowerShell, standard PowerShell, to go and communicate with those switches and set and get properties on them. And there is a logo program that goes with it to ensure compliance as well. So it's basically using OMI, and we communicate using PowerShell. That's, I think, WSMan is the underlying protocol. Okay? So what I'm going to now show is one of the, is us communicating with an Arista switch. So Arista is one of the switching vendors, and we worked with Arista. They implemented an OMI plugin. The standard schema is what they implemented, and now PowerShell has the ability to go and control that switch. And that's what I'm going to be demoing next. Okay. Okay, so the first thing you'll notice is that this is just all PowerShell. I mean, if you know PowerShell, how many folks are familiar with PowerShell to some extent? Okay, great. So this is just standard PowerShell. So the first thing I'm going to do is I'm going to show you what all capabilities, this is a subset, of things can you do with that switch. So for instance, you have the ability to enable switch ports, disable switch ports. You can go get VLAN information, you can set VLAN information, so on and so forth. So you can do basic things basically. You have the ability to do those things. If I want to go and see what all Ethernet ports are on that switch, I can do that. For instance, here you'll see all the different Ethernet ports. I have the name, whether it's enabled or not, what the speed is, what the MTU is, so on and so forth. Okay, so I've just now gotten, and again, if you think about it, this was not possible before. You did not have the ability to use a standards-based model to go and talk to these switches. Going forward, because this is simply PowerShell, this is just PowerShell, so now you can do all kinds of fun things, let's call it that, on these. For instance, if you want to find out all the ports whose names end in a 1, you can do that. You can see that I'm getting Ethernet 1, 11, 21, 31. If I want to go and get specific ports, information on specific ports, I can do that. I can see 1 is disabled, 1 is enabled. I can go and get VLAN information. I can see all the different VLANs that exist on this switch. And now what I want to do is I want to go and, set a VLAN on 2 ports. That's the demo I'm going to do. I'm going to set a VLAN on 2 ports on the switch. I'm going to show that the entities are able to communicate across them. And then I'm going to disable a port and show that I'm not able to show that you can actually control the switch, not just get information from it. So the first thing we'll do is we'll get the ports in question. In this case, I'm getting ports number 1 and 4. I'm going to enable them. I'm going to set the VLAN on that to VLAN 1. And then I'm going to test connection. Test connection is just ping. I'm going to do a ping between the two ports, machines connected to those 2 ports. And like you expect, because the VLAN IDs are the same on both, these are actually able to communicate with each other. No problem. But now let's say I were to go and disable that port. So now I've gone, I set a VLAN, but now I've gone and disabled 1 port. In theory, this should now fail, because now the port is disabled, so you don't have the ability to go and communicate with it. So when I do that, it fails. And this is one of those rare cases where failure is a good thing. And so again, the way to think about this is you have a standards-based mechanism to control a switch, which means that all this kind of CLI that used to exist can simply be written as automatable PowerShell scripts. So you can write scripts along these lines that are fully automated. If you want to bring up a switch, you can use PowerShell to do that. Okay. So what we've seen so far, again, is you have a switch, the virtual switch, you build overlays on top, and then we build gateways that allowed communication across boundaries. That lets you get the benefits of SDN on your existing networks. To get more benefits, with say end-to-end diagnostics, for instance, where you can validate VLANs across the switch and the host, you now have the ability to go and get switches that actually are controllable, manageable via standards-based mechanisms. The last thing that is probably the most important of all is automation. That you have to have automation in place to be able to manage all of this. And System Center VMM and the Windows Azure Pack give you the capabilities to do so. As an example, in our Azure environment, we find that there are thousands of changes that happen on a regular basis. There is absolutely no way any of that could be done on a manually. It has to be done using automation. And System Center VMM gives you the kind of capabilities, gives you the type of constructs that let you get automation that you don't typically get today. And so the kinds of constructs they define are things like logical networks, VM networks, and logical switches. And all these constructs are defined in a way that you change something in that setting, it automatically goes and updates everything else. so that you don't have to go and operate at a per device, per port level that traditionally people have been. You have the ability to operate on much higher level constructs. At the same time that we enable hosters to be able to get automation, it is also important for tenants to be able to get self-service. You know, as an IT, if you're running a private cloud, you don't want to be the bottleneck associated with your customers being able to get to what they need to. And so the idea with tenant self-service is that Windows Azure PAC provides the same kind of tenant self-service experience for the private cloud that's available for Windows Azure today. And this is completely free. So it's available to anyone and everyone who wants to use it. And in the Windows Azure PAC, you have the ability to do the things you'd expect. You know, you want to create your tenant networks, you want to set NAT rules, just all the kinds of things that you'd expect tenants to be able to want to do, get SLAs, chargeback, reporting, all the kinds of things you'd expect tenants to be able to want to do or get, you get that in this experience. Even better, the Windows Azure PAC itself is built on top of an API, and we expose that API, that REST API, so that customers can go and build their own portals, their own experiences on top if they so choose to. So these are basically the technology enablers for SDN. I mean, you have the Hyper-V virtual switch as the policy enforcement edge. This is where all policy gets enforced. You have Hyper-V network virtualization, which gives isolation amongst all the tenants. You have gateways that basically allow for arbitrary topologies that span network virtualization boundaries. You have OMI and PowerShell to be able to go and control your physical network if you choose to. And finally, SCVMM and Windows Azure PAC providing the needed automation and tenant self-service capabilities for these scenarios. So with that, I'd like to invite Dhananjay to come and talk about the SDN ecosystem.
Thanks, Ravi. And welcome everyone who has come here for understanding everything that you want about SDN. I'm excited here. I'm Dhananjay Mahajan. I'm a senior program manager lead on the partner team. And my team works with partners to bring in the innovation and the unique abilities of the solutions that our partners bring in to make our solutions for you as the customer even better. Taking our platform, taking the capabilities that we have built inside of our products, but also making that platform open, flexible, and standards-based so our partners can bring in their expertise, and you as the customer have the choice of bringing in those solutions into your enterprise environments and solving your needs. So to begin with, what I'm going to do is switch over to the demo machine and quickly show you a demo. Is it one? Is it one or two? Sorry. Oh. Oh, sorry. It doesn't seem to be switching over.
No, you don't push.
Oh, don't
You
just
don't
take
push
that?
it.
Okay.
Just like that.
Okay.
And then you do this.
Sorry about that.
This is a 4, right?
This is 4.
Okay, you
I see.
press more. Just press this.
Oh, just press this. Okay. Some help here, please. Sorry about that. I wanted to switch over to the laptop. Number 8. Okay. Thank you. And how do we switch back to the slides? Sorry.
It's just.
Okay. Thank you. Sorry about that. So what I'm going to do is show you the gateway that one of our partners, Huawei, has done. Now, Huawei has built into their core data center switches, the CE12800 switches, a gateway, a forwarding gateway that can connect between physical and virtual networks. And unfortunately, we were not able to get access to where the gateway has been deployed and where we are doing the development and testing. So I'm going to show you a demo, which is a video recording. And let me stop this one. And you'll have to trust me that this is a real working system, but since we were not able to get access to the site due to connectivity issues from this location, we said we'll show you a demo. The demo shows how Huawei's gateway plugin that they've built for VMM can be deployed and then used to connect a VM that we have provisioned over a virtual network to connect to the physical as well as other VMs within that VM network. So using this forwarding gateway, we'll show you how the plugin gets deployed, how we add the gateway, configure the gateway in VMM, then specify the address pool, create a VM, connect it to the gateway, and then get it on the VM network. So here's VMM. We started VMM. As you can see, there's no gateway installed under VMM. Next, what we want to do is go in and register the plugin. The plugin uses some the APIs that are provided by System Center Virtual Machine Manager and help you, as the administrator through VMM, configure the policy. So now the plugin gets installed, and you can see the Huawei gateway showing up with the right versions. Now that you've configured the big gateway, let's create a virtual network, a VM network. Let's call it the Huawei SDN gateway. Make sure that you have a connection string and an administrator as a user account that you can use to connect to the gateway and configure that gateway. Once we have verified that we are able to connect to the gateway, now let's create a VM network. This is your virtual network. Let's call it the Huawei VM network. Configure that network, add the VM subnet to it with our subnet address space. Let's start it configured without connecting through the gateway, so we can test it that when the gateway is not connected, this VM is not able to reach to the outside world. Now let's create a VM, give it a virtual machine name. Once you have given it a VM name, let's configure the network adapter. Use the VM network that we just created. Use one of the available images. Give it an IP address. And once we have created it, the VM starts. And when we connect to the VM via the console, do a ping to verify whether this VM is actually connecting. And the ping times out because you don't have connectivity. The gateway has not been associated with the VM network. We go back, stop the VM, go in, make sure that you have a connection to through the gateway. Now the VM has interconnectivity with the gateway. Start up the VM again and do a ping. And now we have connectivity. So trust me, this is a real working environment. We would have shown you a live demo if we had one. So going back to the slides. So as we said, while we have built great capabilities in the box, we have a rich ecosystem of partner solutions that you can use to deploy this today and even more solutions coming in the future. With Hyper-V vSwitch extensions, many of our partners have been able to build great capabilities with forwarding, capture, and filter extensions, as Ravi was showing. Then we have NVGRE-aware hardware through switching ASICs, which can do much better performance through the task offload in the NICs. And then we have Hyper-V network virtualization gateways. We saw one from F5 and another one that I just demoed from Huawei, both in hardware as well as in software. We also have one from Ion Networks that's available today in the market. And then we have OMI managed switches that help you automate the environment. So a rich partner ecosystem that consists of gateway appliances. Ion Networks is one of the partners we've also been working very closely with. At the last MMS 2013, they announced an entire Ion Pod solution with a gateway appliance, which is available today, and that's a forwarding gateway. They're also offering customers that gateway appliance as part of the Ion Pod, and which will be available to upgrade with R2 when R2 comes out. Then we have the Big IP platform, which has enabled Hyper-V network virtualization. Ravi did a demo of that. And through the Big IP platform, you can get load balancing through the gateway, traffic steering, and access control and security for your applications. Then we also have OMI managed switches through Arista. So Arista has done a SIMMOM implementation in their switches. We use the experiences we had in Azure, as Ravi was mentioning. Over 50,000 different configuration changes happen in the Azure environment. And the only way we can scale to those level of changes is using the automation that's available through OMI and the switches. And Arista has worked with us in their extensible operating system 4.12, which will be released in order to enable that automation. The automation is available not only through PowerShell, as Ravi showed, but when R2 comes out, System Center Virtual Machine Manager will also have the capability to automate switches that are enabled through OMI. Then we have Hyper-V vSwitch extensions. These extensions allow our partners to bring in their unique capabilities. So with Cisco's Nexus 1000V, we are able to interoperate with Cisco's environment and Hyper-V network virtualization with a consistent experience for operations, dynamic policy provisioning through Virtual Machine Manager, and improved security through an integrated environment that provides you to deliver services. NEC has built a programmable flow vSwitch extension in their PF1000, and the SDN controller, the open flow controller that NEC builds, is able to interoperate with Hyper-V network virtualization. So those customers who are using NEC and are having open flow in their enterprises, in their deployments, in their data centers, can use the NEC vSwitch extension. And then Five9 has built a firewall switch, whereas Inmon has also worked with us to build an S-Flow extension, which is Hyper-V network virtualization aware. And then we have NVGRE hardware. As Ravi was mentioning, in order to get better scale, better performance, we have worked with Emulex very closely in their vNex platform that can use task offload to make the Hyper-V network virtualization scale even better than it is. Mellanox, through their ConnectX 3 Pro with NVGRE offloads, has also got great performance enhancements. So as you can see, we have a wide ecosystem of solutions all the way from gateway appliances to NVGRE hardware that gives you a range of solutions that you can deploy and meet your customer needs and meet your own needs. So with that, let me hand it back to Ravi.
Thanks, Dhananjay. So I think that shows the breadth of the ecosystem that we have surrounding the SDN solutions that we talked about today. I'm just going to quickly summarize by just reiterating SDN is the ability for software to dynamically manage the network so that the network appears as a set of pooled resources that you can automate. It does it by effectively giving you the flexibility by abstracting the physical network away, layering a virtual network on top, having automation for deploying policies and a mechanism then to control, to enforce these policies on the virtual switches in the network. We have a variety of technologies that we talked about today: Hyper-V switch, Hyper-V network virtualization, the ability to control switches, multi-tenant gateways, and automation solutions, tenant self-service solutions with SCVMM and the Windows Azure Pack, and a rich ecosystem that's growing along with it. So to summarize, we are going to continue to bring innovation and learning from our data centers and make them available to you. We look at SDN as being a key facet for how customers can go about transforming their data center, and that it's fairly easy to actually go about building these with Windows Server 2012 and System Center, and that we provide an open, extensible architecture that allows for plenty of partner choice in this environment. Thank you.